Well, good afternoon. Today we get to learn about correlation. Correlation is basically telling about the relationship between two variables. For example, in this graph here, subscribers for cell phones, and then over here we have cellular service regions. So what's the relationship between the number of people that you have versus what region they're in? And so you'll notice that these are little points of how many million you have in each of the regions, and you'll notice it has a upward motion as you come in from the right and you go up. That's a positive correlation. And then over here we will notice that the cell phone subscribers versus the let's see, corded phone sales. Oh boy, this is old. So what you would do is you look at the points as subscribers continue to go into the millions. You'll see fewer and fewer who actually have corded phones. So, and this goes down when you go left to right. And so that's a negative correlation. All right. So, we also have such things. Those are called scatter plots, by the way, when you plot all your points on the graph. It's a scatter plot. Sometimes they show positive correlations, sometimes they show negative correlations. Now, let's take a look at this. Tell whether the correlation coefficient for the data is closest to -1, -0.5, 0, 0.5, or 1. Now remember, your correlations will only go between -1 and +1. So let's take a look at this. Look at these points. They're like all over on the graph. There doesn't seem to be really a close relationship here, but you do notice that some things, like as you come across from left to right, it goes downwards a little bit, but they're pretty scattered. So yes, it's going to have somewhat of a negative correlation, but not much of one. So let's take a look. Scatter plot shows a clear but fairly weak negative correlation. So R would have to be somewhere between 0 and -1, but not too close to either one. The best estimate is given is the -0.5. By the way, the R is the math way of shortcutting, calling it correlation coefficient. Correlation coefficient is R. All right. Now, here's another scatter plot all over the place. Look at this. This doesn't seem to be a trend going up or down. It's like everywhere. So if I try to draw a line through it, like this way, no. If I try to draw a line like through it to make it like the same number of points above and below the line, I might be able to draw a line this way. If I draw a line this way, it's pretty flat, isn't it? It's not going up or down. So tell whether the correlation coefficient for the data is closest to -1, -0.5, 0, 0.5, or 1. Now remember, for it to be negative, it'd have to go downhill. For it to be positive, it would have to go uphill. For it to be close to 0, it'd be pretty flat. So let's see what the solution is. Scatter plot shows approximately no correlation. So the best estimate for the coefficient, correlation coefficient, known as R, equals 0. Oh, skipped one. All right, now let's take a look at this. Look at all these points. They're really close together. They're not like spread all over the place. And they seem to be going left to right. I'm going uphill. So I would say that's definitely a positive relationship. And it's pretty strong going uphill. It's not scattered every which way. So the scatter plot has a strong positive correlation, and its best estimate would be R equals 1. Okay, let's have you guys try one out. Okay, here's the scatter plot, and you need to decide if this is a positive or negative correlation, and which one of these R's would be correct. Pause your video, give it a try. Welcome back. Let's see. Positive correlation for sure, because it's going uphill. And R equals 0.5, because it's not real strong. They're kind of scattered, but they are going uphill. All right, let's have you guys try out this one. Pause your video. Welcome back. Let's see how you did. This is definitely going downhill, so it's a negative. Should it be -0.5 or -1? Ta-da! -1, because that's really, look how close together they are. All right. One last one for you guys to try out. Check out this scatter plot and decide what correlation it has and if it's -1, 0.5, -0.5, 0, 0.5, or 1. Pause your video. Welcome back. Let's see how you did. This is no correlation. They're scattered all over the place. And the R would be 0 when there's no correlation. All right. You know how I've been trying to draw like a line with in between, having the same number of points above, same number of points below? What you call that is a best fitting line. Now, to do this, you have to draw your scatter plot. You have to sketch the line that appears to follow most closely the pattern given by the points. There should be as many points above the line as below it. Choose 2 points on the line and estimate the coordinates of each point. These 2 points do not have to be original data points. Find an equation of the line that passes through the 2 points. Let's take a look. Okay, you have all of these points listed here. The table shows the number of Y in thousands of alternative fueled vehicles in the U.S. after 1997. So we take all these data points and we put them on a graph. Here they are. They're all on the graph. Now notice this is pretty much going uphill. Now, we sketch the line that goes through the middle of the points. We have a above, below, below, above, below, on it, above, and right on it. So we try to figure out a point that will make our 2 points to create a line that goes right through the middle of the data. This point is 1,300, and this point is 7,548. Now, you will notice that this point was not part of the original point, and this one was not. Oh, actually, this one here is part of the original points. I'm sorry. And then this one is not. So you don't have to necessarily use the data points that they gave you. And then you have to write the equation for that line. How do you write it? Well, first of all, you take the 2 points, get the slope, 41.3. And then you can plug it into the point slope formula. So the point slope formula looks like this. Here's your point slope. You can plug in either, they chose to use the 1,300 point. So you plug in your 1 right here, plug in your 300 over here, and plug in your slope. Multiply, distributing, and then solve, and you get y equals 41.3x plus 259. Okay? And so that is your best fitting line equation. All right. Final example here. Use the equation of the line fit for example 3 to predict the number of alternative fueled vehicles in the U.S. and the United States. So this was your equation that we came up with, right? Y equals 41.3x plus 259. And because in 2010 is 13 years after 1997, we substitute 13 in for x. So it's 13 years after 1997, so we go, oh, look, put a 13 in for x. And we get 796. So you could predict that 796,000 alternative fuel vehicles will be in the U.S. in 2010. Obviously, this is pretty old stuff. All right, you don't even need that lesson quiz. That's just silly. All right, have a great night, and I'll see you tomorrow.